Hello, my name is Jacob.
My name is Kennedy.
And we are Science Ambassadors at the University of Texas at Arlington. Today we're going to be demonstrating how the volume of a gas will change whenever the temperature of that gas changes. And in order to do that, we have some liquid nitrogen. A cool thing about nitrogen is it is actually the most common gas in the air that we breathe. So all of the air around us is about 80% nitrogen. This nitrogen is liquid. We cooled it down a lot. It's about 300 degrees below zero. That way it is in a liquid form, so it's a lot colder than in the air around us. And we are going to put these balloons in this liquid nitrogen. These are just normal balloons that we blew up with air. So it's just the air from our lungs. So inside of here is also about 80% nitrogen.
So we're going to start putting them in.
So all of these balloons were inside this bucket, and whenever I pulled them out, it might have looked like that they were deflated or flat or that the air was taken out of them, but if you look at the bottom, each one of these still has the knot in this. So we weren't adding any new air. The air that was in them actually just contracted whenever it got very, very cold in the liquid nitrogen. And then as we pulled it out, it started to expand and get bigger, and that's why it looked like the balloons reinflated. This is because of something called Charles' Law. Kennedy, do you want to explain Charles' Law?
So if we take two fists, and these will represent molecules, when the balloons are out in their room temperature, gas molecules are going everywhere. They are within the balloon, bouncing, vibrating, moving all around. And as we put them inside of the liquid nitrogen, they're still vibrating. They're just moving closer together, vibrating closer together, which is how our balloons became flat inside of the liquid nitrogen, because the liquid nitrogen is 300 degrees below zero. And as we put them back in room temperature, the gas molecules are still vibrating, but they're expanding again, and that is how the balloons were able to regain their shape.
So that is how, whenever the temperature of a gas changes, the volume of that gas also changes.
Another example of Charles' Law is what we're going to do with this flask. We're going to blow up a balloon. And put it on top of the flask.
Maybe not.
And now that that's on there, we're going to lower it into this liquid nitrogen. Perfect. So now our balloon is inside of the flask. Put it out. Oh, it's immediate. So this is a similar effect as the balloons inside of the liquid nitrogen, because the temperature in the glass dropped, and as it was dropping, the balloon went inside of it, and now that it's warming back up again, the pressure pushed it back out. So it is re-expanding. Thanks for watching.